Hello, hello. We are going to quickly finish up lesson 6.6 that we did not get to in class. So in the packet that I gave you guys on Tuesday, I'm on page 5, and it looks like this: constructing polynomials. So before we jump into this, I want to actually start with something that you might be a little more familiar with. So let's say I have a quadratic polynomial. X squared plus 7x plus 10. So this is a polynomial. And I can rewrite a polynomial in its factors. So if I were to factor this, I would end up with x and x, and I would have x plus 5 and x plus 2. So these are factors. However, if I wanted to find the roots or the zeros of this polynomial, I would then take each of these factors and set them equal to 0, and then solve. And these are my zeros or roots. So this is basically the process we've been doing. I've been giving you a polynomial, and you have to find the roots or the zeros. In these notes, I am going to give you the zeros, and you have to come up with the polynomial that would have those zeros. So I want to actually start with example 9. So it says, for each example, write the simplest polynomial function with the given zeros. So we are told that this polynomial has a 0 at -3, at 2, and at 1. So these are the zeros. Now, since there are 3 zeros, I know that my final polynomial is going to be a cubic function, degree 3, because our fundamental theorem of algebra tells us that however many zeros there are, that's the degree of the polynomial. So the first step is to take our zeros and turn them into factors. Okay, so I'm going to take my zeros and turn them into factors. So if x equals -3 is a 0, that means x plus 3 is a factor. If x equals 2 is a 0, that means x minus 2 is a factor, and x minus 1 is a factor because 1 is a 0. So again, here's our other example that we did. This is now like where we're starting. We're starting with this, and now we're going in this direction. So I started with the zeros, and then we're going to turn them into factors. And now I'm going to multiply these together to get the polynomial. I can't multiply all 3 of them together at once. I'm just going to do the first 2. So I'm just going to ignore that third factor for a moment. So I have x times x is x squared. X times -2 is -2x plus 3x minus 6. I can simplify that a little bit. So I have x squared plus x minus 6. And then I'm going to take this and multiply it by the last factor. Go through and multiply it. X cubed minus x squared plus x squared minus x minus 6x plus 6. Then I'm going to simplify. So my x squared terms cancel out. I get x cubed. Those go together, minus 7x plus 6. So what that means is if I were to take my calculator and graph this polynomial, x cubed minus 7x plus 6, it would hit the x-axis at -3 and 2 and 1. Okay, so before we move on to examples 10 and 11, I want to talk about when we get kind of funky zeros. So either imaginary roots or zeros or irrational roots or zeros. So essentially what you need to know is that they always come in pairs. You guys worked on pages 6 through 9 for homework this week, and all of the answers, right, the answer keys on page 10, I want you to look. Anytime we had imaginary answers, they always came in this like plus or minus pair. 2i and negative 2i, 3i and negative 3i, 1 plus I times the square root of 23 over 2, and 1 minus I times the square root of 23 over 2. So imaginary roots always, always, always come in pairs. Same thing with irrational roots. So square root of 5 is not imaginary, it's a real number, but it's irrational. Irrational roots also come in that plus or minus pair. So that's what we need to understand here with this. So the irrational root theorem says that if a polynomial has a root of a plus the square root of b, then a minus the square root of b must also be a root. So we get that plus or minus there. So for example, if 1 plus the square root of 3 is a root, 1 minus the square root of 3 goes with it. If negative square root of 7 is a root, positive square root of 7 is also a root. Those are the pairs that go together. Same thing with imaginary. Complex is another word for imaginary. So if a polynomial has a root of a plus bi, then a minus bi must also be a root. We get that plus or minus again. So what goes with 6 plus 3i? 6 minus 3i. What goes with 4 minus I? 4 plus I. So why is that important for these last examples? Well, in example 10, we are told that x equals I is a root. Now, they don't tell us this, but you have to know that if I is a root, x equals negative I is also a root, because the imaginary roots have to come in pairs. So even though it doesn't list negative I has to be on the list. And then we also have x equals 4. So again, first thing I'm going to do is turn my zeros into factors. So if x equals I, that means I have x minus I, and then I have x plus I, and then I have x minus 4. So those are my factors. Now, I would highly recommend multiplying the paired factors together first. It's going to make your life way easier. So we're going to do x minus I times x plus I. So I have x squared. X times I is ix. Then I have a negative ix. Negative I times I is minus I squared. All right, now let's simplify this. Well, ix and minus ix cancel out, and I squared, remember, equals negative 1. So I have minus negative 1, which is really plus 1. So that all just simplifies to x squared plus 1. Kind of crazy. Then I have x minus 4, and now I'm going to multiply these together. So I have x cubed minus 4x squared plus x minus 4. And that's it. Okay, one last one. Again, we have our irrational roots. So if square root of 2 is a root, then negative square root of 2 is a root. We get that plus or minus pair. And then my last one is x equals negative 1. So my factors are going to be x minus the square root of 2, x plus the square root of 2, and x plus 1. All right, we're going to multiply the paired factors together first. X times x is x squared. Then I have plus x times the square root of 2 minus x times the square root of 2. And when I do square root of 2 times square root of 2, I can actually multiply those together. So I have minus square root of 4, 2 times 2. Those cancel out, And 4 is a perfect square. The square root of 4 is just 2. So I'm left with x squared minus 2. Then I'm going to multiply by that last parentheses there. And when you FOIL all that out, you're going to get x cubed plus x squared minus 2x minus 2. All right, that is it. We will see you on Tuesday.